Okay, here we go. Trig ratios of any angle. Have to open it twice. Okay. Let's see, what are we against here? 24 questions. None. All right, let's get on. Use a calculator to find each round your answers to the nearest 10,000th. That means 4 decimal places. Note, the secant function is defined in the following way. The secant of theta is 1 over the cosine of theta. Thus, this becomes 1 over cosine of negative 195 degrees. Now, although we're not asked to do this, I personally want to see if I can simplify this. So, I know that the cosine function is even, which means that it's symmetric about the y-axis, and therefore I can turn this into I can turn this into 1 over the cosine of 195 degrees. Then I know that it follows that shape. So the minimum, which is -1, is at 180 degrees. Then it just goes on 15 degrees more. And let's see, what would that be? Oh, so it would be the negative of cosine of 15 degrees, I believe. $15 degrees, that's one of those special values, but perhaps I can figure it out for myself, right? So that is cosine of 45 degrees minus 35 degrees. And this is one of the difference formulae. Now, I believe that it's cos A cos B minus sin A sin B, but I'll have to check because that is one that I frequently forget. So trig difference formulae. Here we go. Here we go. Oh, sorry, beg your pardon. It's the opposite sign, isn't it? Yes, it is. So it's cos A cos B. In this case, it would be cos A cos B plus cos A plus sin A sin B. And thus, I would have to sort of flip this, wouldn't I? All right. Okay, so minus 45 plus 35. Wait, what am I doing? It's a difference formula, so it will work, won't it? Yeah, it will work. All right. Cos A cos B plus sin A sin B. Cos 45, I know that that's root 2 over 2. Sin 45, likewise, so root 2 over 2 outside of the brackets. And inside the brackets, cosine of 30, that would be root 3 over 2. Sine of 30, that would be a half, so root 3 over 2 plus 1/2. And so, in total, this should be root 6 plus root 2 all over 4. That is one that comes up quite a bit. Now, first, I'm going to check. I'm going to run the risk of being wrong. That's fine. Root 6 plus root 2. And then all of that divided by 4 is that 0.9659. Okay. And now I'm going to check 1 over cosine of Negative 195. Okay, just all right. Right, okay, so let's check. Right, I'm positive there's no mistake at that stage. And now cosine of 100. Oh my goodness me. Did you see that? I dropped the reciprocal nature of it. And so all of this will be 1 over, won't it? And thus, it'll be 1 over this. And so we obtain that. And we obtain 1.0353. 1.0353. Right, but where's the negative sign coming from? There. Right, okay, so I dropped the negative sign as well. Okay, but otherwise, the reasoning was valid. $1.0353. Okay, cosine of 13 pi over 12, that's in radians. Now we know that okay, so we're still going to try. So at cosine of pi, it's at its minimum, and then it goes on by 1/12 of pi, and that will be the negative of cosine pi over 12, or pi by 12, as a lot of people say. And pi over 12 radians is 180 divided by 12, which is cosine of 15. So that looks to be the same. So we're going to place our bets. Oh goodness, what? Oh right, because I'm not paying attention. Okay, that's secant right there. This is just regular cosine. Okay. Okay. Of course, it can't be bigger than 1. Coming guns a-blazing. And I'm making these mistakes. 9659. Slow down. Take care. Okay, great. And the minus sign, please. Hello. Find the exact value of each trig function. Okay, so sine of 510 degrees. The period is 360, so we take away 360 just to begin with, which gives 150. And then so what will that be? That will be the same as sine of 30, which is a half. Okay, cosine of... hold on. Careful now. Okay, good. Cosine of 585 degrees. It's periodic over 360 degrees, so we take away 360 to get 225. thinking about the symmetry, so it goes down to what goes down to the minimum at 180, and then climbs back up by 45 degrees. So it will be the negative of cosine of 45 degrees, I believe. And that will be the negative of root 2 over 2. Next up, the tangent function. Now, the tangent function is an odd function. So tan of negative 21 pi over 4 is the same as negative tan of 21 pi over 4. The period of the tan function is pi radians every 180 degrees. And so we can subtract 16 from the numerator and it should stay the same. Isn't that right? That is right, isn't it? No, we can subtract 20. That's even better. Okay, so we get the negative of tan of pi over 4. Pi over 4 is 45 degrees. It's 45 degrees. And therefore, wait, what's tan of 45 degrees? That will be 1, and therefore this will be negative 1. Okay, I mean, I should really be able to tell that at this stage, but, you know, I want to go through reasoning as well as instinct here. So what does my instinct say? I just look at it and I just say 0, right? But we'll see. Okay. No, that's a good way. Intuition, then go through reasoning and then compare. Okay, it's a way to like refine your intuition. I'm thinking. Okay, negative 3 pi over 2. Cosine is an even function, and therefore this will be the same as cosine of 3 pi over 2. Translation, that's cosine of 270 degrees. Following the shape of the graph, that's clearly 0. So it's okay. Next up, we don't have the sort of cast diagram to sort of assist us. I didn't actually use it, to be honest. Okay, here. So cosine has a period of 2 pi. So we subtract 16 from the numerator. So it's the same as cosine of pi over 4, which is 45 degrees. Cosine of pi over 4 is root 2 over 2. Okay. Negative 180 degrees. Once again, it's an even function. So the cosine of negative x is the same as cosine of x. Its period is 360 degrees, so take away 720. And we get cosine of 90 degrees. A special value, which we should know, is 0. Cosine of 9 pi over 4, 8 pi over 4 is 2 pi. That we deduct. So it's the same as cosine of pi over 4, which is the same as cosine of 45 degrees, so it's root 2 over 2. We subtract 8 from the numerator. So it becomes 7 pi over 4. Okay. And what is that? That's sine of 135 degrees. Then we, wait 1 second. Is that right? No, that's not right. Beg your pardon. It's 360 minus 45, which is 315 degrees. So we just think about the shape of the graph, and it should be negative root 2 over 2. Okay. Sine of negative 9 pi over 4. sine is an odd function, and therefore we just need to put the minus sign outside. The period of sine is 2 pi in radians, and therefore we can subtract 8 from the numerator, and it will stay the same. And pi over 4 radians is 45 degrees, and thus it's the negative of sine of 45 degrees, which we know to be negative root 2 over 2. Tangent is an odd function, and so tan of negative x is negative tan of x. So it's the negative of tan of 945 degrees. Its period is 180 degrees. So 180 times 5 is 900. We can take that away from the argument, and it will stay the same. The tan of 45 degrees, something we should know, is 1. So it's going to be negative 1. Next up, sine of negative 720. So I believe this is just simply 0. Cosine of 4 pi over 3. Okay, so this is, what's that going to be? 240 degrees. In other words, so it'll be the, let's think here. Okay, so following the shape of the graph, it will be the negative of cosine of 60. Or in radian language, that will be, what is that? Pi over 3. Right, but secretly, internally, we use degrees. Okay, and that's negative a half, I believe. Use a given point on the terminal side of angle theta to find the value of the trigonometric function. Okay. Right, okay. There's a fair bit going on here. What the heck are they even asking me here? Wait, do I have to find it exactly? That's not exact. Okay, so we have a right triangle that is root 15 on the smaller leg and 7 on the larger leg, using arctan of theta. Arctan of 7 over root 15. That obtains that angle there, and then we just take that away from 360. And we render it as it's negative, as it's going around clockwise. To find the value of the trigonometric function indicated. Right, well, we'll just see for a second. Okay, so I mean, it looks about right. Okay, And then the negative of that. No. Okay. Because of that there. All right. I guess I get what they're asking me. Okay, there has to be a simpler way of thinking about this because this is kind of silly, it seems, kind of foolish. All right. If the shorter leg is root 15, the longer leg is 7, then the hypotenuse is 49 plus 15, which is 64, and that amounts to 8. And sine of theta is defined as a ratio to be the opposite side divided by the hypotenuse, which in this case would be 7 over 8. I'm just sort of thinking about like why it's going clockwise. It's perfectly valid, but all right, whatever. Moving on. Okay. Cotangent of theta as a trigonometric ratio, by definition, is the adjacent divided by the opposite. And so this here has coordinates 17, negative 13. And so we can just really use what's actually told to us right here. So we could say 17 over negative 13, right? However, it's going clockwise. So okay, here secant of theta being the reciprocal of cosine theta will be the hypotenuse divided by the adjacent. And here the hypotenuse, as previously calculated, is 8. So that will be the negative. No, it'll just be 8 over 7. Symmetric. All right. Rather even. It's an even function. Okay, now sine theta. Given that point there is 5, comma, negative root 11. Okay. 25 and 11, that's 36. So that's 6. So 5 over 6. Okay, so negative 5 over 6. All right. Find the exact values of the 5 trigonometric ratios not given. Well, we can say for sure that tan of theta is that, can't we? Okay, so how do I work this out again? No problem. I'll try. I'll just remember times sine over cosine theta. All right. So we have this, and that's equal to this. Okay, so how do I get it? You have to think. Come on. Try and think about what it's actually saying. Yeah? So, it's like okay, so sine is positive there, and there, and negative there, and there. So unfortunately, it's not down there. It's actually over here. Okay, now I go -1 that way, and root 7 up. What I'm asking you to do is to try and think about what sine of theta is logically. Okay? There's theta. We already know what the tangent of theta is. Now think. Well, the hypotenuse would be root 50, wouldn't it? Right. So it's the opposite, which is root 7, and then divide that by root 50. So root 7 over 50. But notice this here can be simplified to 5 root 2. And then you can times the top and the bottom by root 2. So it becomes root 14 over 10. So try that. Now check. Okay, root 2 over 4, which is nowhere close. Root 2 over 4? How? How? What? Right, I have to understand this. I really, really have to understand this. Okay? Because here's the thing. Like, there'll be awkward topics that you develop a few little tiny tricks for here and there, and then you get lazy. And the real way to do it is to confront them. Confront the things that you don't really feel that you truly understand, but that you've just sort of got a few tricks here and there that get you by. Okay? So, let's think. Okay, so we're told cotangent of theta is negative root 7, and that the sine of theta is root 2 over 4. So figure it out. Figure it out. How to get from there to there. Okay. So that is adjacent over opposite. So it doesn't matter where we draw the point. Just do it there. Okay. There. There. Now, how is that possible? Come on, how is it possible? Well, the hypotenuse the hypotenuse is 8. The hypotenuse squared is 8, which when you square root it is 2 root 2. And sine of theta is defined to be the opposite of the hypotenuse, right? Okay, so so 1 over 2 root 2, surely. Okay, now times the top and the bottom by root 2. Rationalize the denominator, right? Okay, I did it. Now stare at it and understand why that's true. And now try to find cosine of theta. Okay, cosine of theta is the adjacent over the hypotenuse, so it'll just be negative root 7 over 2 root 2, no? Which is negative root 14 over 4. I believe, for now. I haven't checked yet. And then the reciprocal function, that should be fine. But you have to rationalize the denominator, don't you? So we get 4 root 14 over 14, which turns into 2 root 14 over 7. Just a sec. All right, so we have that. And finally, cosecant, which is the reciprocal of that. And rationalize the denominator, and we get 4 root 2 over 2, which turns into 2 root 2. Now check. Okay, that's valid. That's valid. Okay, that's good. Now, how am I going to have a good strategy for this in the future? Find sine, cosine, and tangent, and then you get the reciprocal functions for free. Just do 1 over those results that you get. You imagined which quadrant it was in, paying attention to the condition that sine of theta had to be greater than 0. That's why it was there and not down there. And then you just made a simple small diagram here, which helped you out. Okay, now do it again without looking. Sine of theta has to be greater than 0. Okay, so it'll be over here. Cotangent of theta is the adjacent side of the triangle divided by the opposite side. So the adjacent side will be negative root 7, and the opposite side will be 1. So there it is there. So the hypotenuse of this triangle here, will be that squared plus that squared square rooted, which is 2 root 2. And so sine of theta will be 1 over 2 root 2 right, which is root 2 over 4. Next, cosine of theta. You only need 3 functions and then you get the reciprocals for free. Okay, cosine of theta is adjacent over hypotenuse. So it'll be negative root 7 over that. Top and bottom times by root 2. So negative root 14 over 4. And then get the others. Four over root 2, but we don't write that. We write 4 root 2 over 2, which becomes 2 root 2. Negative 4 over root 14, but we don't write that. We write negative 4 root 14 over 14, which we turn into negative 2 root 14 over 7. And finally, the tangent of theta will be 1 over negative root 7, which will be negative root 7 over 7. Okay, now for this one. Okay, so sine of theta is less than 0, huh? Okay, so that means it can't be in the top 2 quadrants. And in fact, I think it will have to be here. Because if I think about the shape of the cosine function, it returns to positive here in this quadrant, doesn't it? Anyhow, let's do it. So cosine of theta is adjacent divided by hypotenuse. All right. So, you know what? Switch to a finer pen. That's 25. And the x-coordinate of that will be 24. Now, 25 squared is 625, and 24 squared is 576. And the difference between those is 49, and therefore this will be 7. It doesn't look like it, but it is. Okay, so now what? Now, try to obtain sine of theta. Okay, sine of theta is opposite over hypotenuse. So, I believe that it will be 7 over 25. Incorrect, because it's negative. Okay, fine. Notice that this should be negative 7 over 25. Okay, and now tan of theta is opposite over adjacent. So it should be negative 7 over 24. And now the others should come for free. So let's do it. Okay, now check. Okay, sine is correct. Tangent is correct. Cosecant is correct. Secant is correct. And cotangent is correct. Good. Now try again. Okay, we're told the value of sine. Now, we're told that cosine of theta is positive. Now, cosine is positive where? There and there. And sine is negative. Where is sine negative? There. So it's in the fourth quadrant. So like that. Now the cosine of theta is the adjacent divided by the hypotenuse, but we don't have the hypotenuse, so figure that out. 2 root 5, when I square it, gives me 20. When I square that, it gives me 25. Add them together, you get 45. Take the square root, you get 3 root 5. So write that there. Now, the adjacent in this case is 2 root 5, and divided by the hypotenuse, which is 3 root 5. Now get the tan function, the tangent of theta. That is the opposite divided by the adjacent. The opposite is -5, and the adjacent is... Hold on just a minute now. Hold on just a minute now. That's completely wrong. So fix it. Okay. Here we go. So we're told that sine of theta is -2 root 5 all over 5. Sine of theta is the opposite side divided by the hypotenuse. So the opposite side we can confidently say is 2 root 5 in the triangle. So it should be there, -2 root 5. Okay, the hypotenuse is 5. Now you have to figure out the adjacent, which is the x value. So square 5 to get 25, square 2 root 5 to get 20, and then take the square root of that. Take the square root of the difference, beg your pardon. The difference is 5, so that should be root 5, just like that. Now, for cosine of theta is defined as the adjacent over the hypotenuse. So it should be root 5 over 5. And it's positive, and that's good. Tangent of theta is defined as the opposite over the adjacent. So that will be negative 2 root 5 over root 5, which becomes negative 2. And now you get the other functions for free. So cosecant of theta is the reciprocal of that, which is negative 5 over 2 root 5. Rationalize the denominator, and you get negative 5 root 5 over 10, which is negative root 5 over 2. Then comes secant of theta. That will be 5 over root 5, which by definition is root 5. And then comes cotangent of theta, which will be by definition negative a half. Next. We're told that the tangent of theta is negative 5 and cosine of theta is positive. Where is cosine of theta positive? In the first quadrant and in the fourth quadrant. Where is tangent of theta yield? Where does tangent of theta yield negative results? In the fourth quadrant. So the triangle that you're thinking about is situated in the fourth quadrant. So just draw it. Just like that. Now, tan of theta is defined to be the length of the opposite side divided by the length of the adjacent side. Opposite over adjacent. So, we know that that's the opposite side and that's the adjacent side right there. Call the adjacent side 1, which makes sense because that's 1 unit to the right, and call the adjacent side call the opposite side negative 5. And now our job is to find the other trigonometric functions. So let's start out with the sine function. Now we've got the adjacent and the opposite of this triangle, this right triangle, but we don't have the hypotenuse. So just use Pythagorean theorem. That's all. Square that, add them, and square root it. And you get root 26. Root 26. So sine of theta is the opposite side, which is negative 5, over root 26. Negative 5 over root 26. We rationalize the denominator, and we get negative 5 root 26 over 26. Okay. Cosine of theta is, by definition, the adjacent side divided by the hypotenuse. So that's 1 over root 26, but we rationalize the denominator. So we get root 26 over 26. And now the other functions come for free. So cotangent of theta is negative 1/5. Cosecant of theta will be the reciprocal of this, which is okay, it's a little bit tricky at this time to do in my head. Okay, so we get 5 times 26 on the denominator, which cancels out. There. And here, secant of theta. Well, that would be 26 over root 26, which by definition is root 26. Okay, now before we do the last two, let's check. Let's make sure that we're doing it right. Okay, that's correct. Tangent of theta, that's correct. Cosecant of theta, that's correct. Secant of theta, that's correct. Cotangent of theta, that's correct. Here, same story. Yes, 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 and yes. Brilliant. So we're really getting this topic now. Okay, we're told that the cosine of theta is negative. Where can it be negative? In the second and third quadrant. Cosecant of theta is positive, and seeing as how that's defined as 1, hold on. Well, that's defined as 1 over sine of theta, and where is sine? Positive in the first and second quadrant. So it's going to be here. Now, we know that, all right, so what's the definition of cosecant of theta? 1 over sine of theta, and therefore it's the hypotenuse divided by the opposite. The hypotenuse divided by the opposite. And so, what do we know? Well, we know that wait. What's 3 times root 7? Can't believe I'm asking that. Right, okay. Fine. Just checking. Okay, so cosecant of theta is the hypotenuse divided by the opposite. So 3 root 7 is the hypotenuse, and the opposite there is 7. So there we go, 7 right there. Now, as for the x coordinate, we don't know that, so we're going to square this. So we obtain 63, right? Yes, 63. Square that to get 49, find the difference, and square root that. So we get 63, take 49 is 14. So that'll be root 14 along there. So negative root 14. Now that we have all the pieces that we need, it should be a simple job to get all the remaining pieces that we need. So let's just show that. We'll just go arbitrarily here. Sine theta, that's the opposite divided by the hypotenuse. So that'll be 7 over 3 root 7. Cos of theta, it's the adjacent divided by the hypotenuse. So that And I tell you what, man, why did I do that? That's just inefficient. It's just so inefficient. Anyway, fine. We'll just proceed as if like we just didn't know what the other ones were. Okay. Tan of theta is opposite over adjacent. Okay, now just rationalize everything. That should be fine. Negative 7 root 14 over 14. Negative root 14 over 2. Those cancel, so you get negative 3 over root 2. So negative. There. That's what I believe it is. That's what I believe it is, but I don't know. Okay, one last one here. If it's difficult, it's good. That means growth. That means growth. Okay, so secant of theta equals 2. And sine of theta is negative. Where is sine of theta negative? Third and fourth quadrant. Secant of theta is 2. Okay, so where is secant negative? Exactly where cosine is negative. And cosine is negative in the second and third. So it's going to be here. Okay. Secant of theta. Come on. There. Hypotenuse over adjacent. So what does that mean? Okay, that means that the x value is negative 1, and the hypotenuse is negative 2, even though that doesn't... I know. I'm not saying that. Okay, now figure out the rest. Okay, 2 squared, take 1 squared, that's 3. Square root that, that's square root 3. And that'll be negative as well. So minus 1 minus root 3. Okay, we have it. So now obtain what sine is and obtain what tangent is. Okay, so sine of theta is opposite over hypotenuse. So what will that be? That will be negative root 3 over 2. Fine. Tangent of theta is opposite over adjacent. So what's that? Negative root 3 over -1, which is root 3 over 1, which is root 3. Okay. Now the other functions come for free. So here we go. Okay, so cosecant of theta should be -2 over root 3, which when we rationalize it is -2 root 3 over 3. There. And finally, cotangent of theta should be 1 over root 3, which is root 3 over 3. Now check. Check everything. Correct. 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 That's right. And wait. Oh, yes, that's right. Okay, fine. Next up. Okay, that's correct. That's correct. So is that. That one's not. Neither is that one. Okay, why did I not spot this? That should be negative, but why did I not spot it? It's in the third quadrant where, because the negatives cancel out, obviously. No, they don't. No, because look, it says it's negative root 3. So why is it saying that? Why is it saying negative root 3? Did I get anything else wrong? No, you got the sign right. And of course you got cosecant right. Okay, I dispute this. I don't actually believe this. Okay, graph secant of theta and graph tangent of theta. Now, where is secant of theta 2? Just type in y equals 2. There. I don't understand. Nope, sorry. I don't understand that one. I'll have to come back to it. Wait, did you check these? I think so. Well, double check. First of all, there is a minus sign missing right there. Then should come a half. Then that, okay, that's fine. Good. Good. Okay, they're all valid. And this is false. So is this. And so is this. Okay, so you're going to have to do these entirely again. Goodbye. And slow down and go through the reasoning. Okay, so what do we have? That says root 15, that says 7. So the hypotenuse of this triangle is 15 plus 49, which is 64, square root that's 8. So sine of theta is defined to be the opposite over the hypotenuse. So in this particular case, it should be 7 over 8. Okay, but that's a positive angle, so it's going backwards. So, but that won't affect it. It will still be positive. That's fine. In that quadrant, it will be. Okay, so now cotangent of theta. So that is defined as the adjacent over the opposites. And in this particular case, it's 17 to the right, negative 13 down. So shouldn't that simply be negative 13 over 17? Wrong. No. Why is it wrong? Well, because you're going backwards. What do you mean? I mean that these are positive angles. Okay. That doesn't really help me much. Think about the shape of the graph, the tangent graph. Okay, now think about the shape of the cotangent graph. Okay, so that should be positive then, shouldn't it? Good. Now, secant of theta is defined as what? 1 over cosine of theta, which is, so it should be the adjacent over the opposite. And in this case, we're told what those are. Negative root 15 and 7. But notice a positive angle. Okay, so it doesn't make a difference. Cosine is odd. No, sorry, cosine is an even function and therefore secant is. All right, okay, fine. How about sine of theta? Well, sine of theta is the opposite over the hypotenuse. Do you know what the hypotenuse is here? No. So 25 plus 11, square root that, you get 6. That's the hypotenuse. Okay, so it should be the opposite divided by the hypotenuse. But then it's positive angles. That should be fine. It should be a negative number. Okay, now check. Correct. Wrong again. Wrong again? Okay, this one was right. Okay, then it's official. It's official. I don't understand why I'm wrong. Adjacent over opposite. Think about it. The adjacent is obviously 17. Goodness me. Goodness me. Goodness me. 17. Do that and then worry about if it's positive or negative. Worry after. Okay, so a small positive angle for the cotangent function. It should be negative, right? And it is. Okay, so stop worrying. Okay, now secant of theta. Here, they include the number 8. Why? I don't know. That's what we're supposed to figure out. Okay. The adjacent side. Oh my God. The wrong definition. That's what it is. It's the wrong definition. Secant of theta is 1 over cosine of theta. Now, cosine of theta is the adjacent over the hypotenuse, so secant of theta must be the hypotenuse over the adjacent. Don't you know? Now, the hypotenuse is 8, and the adjacent is negative root 15. Top and bottom, like rationalize the denominator. And now figure out if it will be minus or plus. Okay. It will be minus based on how the graph looks. And it is. Okay. Please don't tell me. Oh, wait. It is. Even more stuff like this. Good. But first, hydration. Wow. I'm going to be dreaming of trigonometric functions tonight. Good. Okay. Find the amplitude, the period, the phase shift, the vertical shift, and minimum and maximum values. So basically find everything. Okay. Amplitude of such a function. The answer to that is 3. And the period of this function will be 2 pi. And the phase shift, I don't know what that is, but I'm going to guess that it's negative 5 pi over 6, like the amount by which it's translated. But having that there actually translates it to the right. So I'm going to put a plus there for now. The vertical shift, 0, I think, and the minimum and maximum values will be that. So I'm going to check and see if that's correct. Okay, that's actually correct. Okay, I like that. But I didn't graph it. So I must graph. So it will be 5 pi over 6 to the right. So what I'm going to do is just draw sine of, I'm going to draw it without shifting it first. So I'll do that. Then what? Then I'll do that and that and that there like that. And in fact, I'm only going to draw one period of it unshifted. And now I'm going to think about what does it mean for that thing to go 5 pi over 6 to the right. So I'm literally sweating thinking of this. Okay, so careful now. If that's 3.5 little units, that'll be 3.5 little units on as well. And so will this one. And so will this one. Just there, like. Oh my God, I didn't do this one. There-ish. Okay. Now, So, oh my goodness me, look at that. 4 square units separate the camel hump. Okay, so oh man. That was bad. What? Okay, it's difficult to see. Look, that's reasonable, isn't it? Yes. All right. Now, the amplitude of this will be 3. A vertical stretching by a factor of 3. The period is 2 pi, just like regular cosine of theta. The phase shift will be nothing. The vertical shift will be nothing. And the minimum and maximum values will be -3 to 3. Okay. This one's really not so bad. But it is bad if you do that. Okay. Cosine is sort of like a valley. And the thing about these graphs is like, oh, what's the point in being accurate? That's the whole point of mathematics, to be accurate. It's the one place where you actually get to be correct, right? So anyhow, what's going on with this? Okay. Oh, it's all bumped upwards. Okay, so wait a minute. What does amplitude mean exactly? Amplitude means from the line of symmetry, the horizontal line of symmetry, up to the peak. That's what that means. It doesn't mean double that. It doesn't mean double that. All right, so this should be, it should have an amplitude of, wait, did we check? We did? Okay, that's good. This should have an amplitude of 2. It should have a period of, I don't know, do I? Yes, I do. Just think. Uh, 2 pi over 3. It should have a phase shift. Oh no, oh no. They're doing this thing. See, I want to say pi over 2 to the right, but I know that this is going to interfere with that. I already know it. Just factor it out. Just like this. Oh no, that has absolutely no sense at all. Like that. Okay, the min and max, that I can surely obtain. That will be 0 to 4. What were the other variables? Vertical shift, that will be 2 units upwards. And I don't know how to handle this, so I believe it's pi over 6. But I don't know. I don't know. So I have to check. Okay. The factoring is correct, because then I interpret this as going to the left by pi over 6, which is what it is, which is what it does. So I'm just quite literally going to write the word left. But I don't know how to actually graph it. I know it will look something like this, right? And that's good, because it won't look ridiculous when I do it. But how to get it accurate? How to get it accurate? Just feed in three values. That's all you need to do. Okay, so feed in three values. No, because that's not developing a sense for what actually happens to the function. You're just feeding in values, drawing dots, and then pretending that you know what the rest of the function does. Think about it logically, step by step. What does each number actually do? Okay. Plus, isn't this just a recipe right here? Shouldn't that be clear? Okay. So I know that it's going to be bounded here and here. That's fine. And I know that the period is 2 pi over 3. So I just have to know two-thirds. I just have to know what's happening in that tiny little rectangle right there. And then it will repeat forever. Right? That much I do know. Okay, so... Oh, and also, I know that I'm going to see this. So, or, you know, the two camel humps, the S shape. But I don't know how to get the rest. I think it's a good idea to input 0. I do. If you input 0, then what do you get? What's sine of negative pi over 2? Well, that's sine of negative 45, is it not? Wake up. Sine of negative 90. Hello. Negative 90, which is negative 1. Multiply that by 2 to get negative 2, add 2 to get 0. So it should start down there. The sine function has nowhere to go. When it's down there, it's at its minimum, so it has to go upwards, doesn't it? So it will be like that. And check. And that's correct, and that's good. So what you can do, 2/3 add another 2/3 is 1 1/3. I get it. Just like that. It will look sort of like this, won't it? Yeah. All right. Way too long on that. Okay. So, next one. Amplitude will be 1. The period of this function will be 4 times longer than usual. So what, 8 pi? The phase transition, factor out a quarter, like this. Then how do you interpret that positive pi? Okay, negative pi to the left. Is that the word for it? No, it's called the phase shift. Phase shift. Okay, now the vertical shift. Well, it'd be -2. If I say -2 down, that sounds like do not, blah, blah, blah. Okay, so I'm going to do a downwards arrow. And then the min and max. What are those? That's what it will be. Okay, now actually get on with it. All right, so do this so that your result doesn't look totally ridiculous. Okay, so you know that it's going to be you're going to witness the period inside here. Okay, fine. Next. Now, what you're confused about is not what it will look like inside there, because you kind of roughly know. You still don't know how to do this, do you? That's the issue. That's correct. So, okay, what I think is, if it says negative pi to the left, I think that it will look like how I expect it to look like. Whoops, that's actually wrong. Right, do like gray for the helping function. Oh gosh, can you not? Or can you? That's better. Like that. Okay, now What does it mean for that thing to go pi to the left? What will that look like? Okay, instead of that being there, it will be over here. I think that's what that means. No, the better way to think about it is that instead of that peak point being there, it will be over here now. See? Instead of that midpoint being there, it will be there, and that will be there, and that will be there. That's what I think. That's what I think. Okay, time 2. But get it accurate. There's just no point. No point in doing any of this if it's not accurate. You may as well doodle. All right, so check. Okay. Oh boy. Oh boy. Okay, so it's right, but like the shift is not right. But how does one do this? Seriously, how do you do this? Okay, so instead of it being 9 pi, it's actually 7 pi. I don't know how to do it. Okay, just think for a bit. Put a star next to it. Let it marinate. Mentally marinate. Find the period in radians, the phase shift in radians, the vertical shift, the two vertical asymptotes, if any. Then sketch the graph using radians. This is never going to end. And it's good that it will never end. It's good. Okay. The period of it will be pi over 2. Not doing that phase shift yet. The vertical shift will be -1. The asymptotes are things that I don't know yet. So, what about the phase shift? Factor out the 2, you get theta minus 11 pi over 12, like that. And so it will be 11 pi over 12 to the right. I'm seriously running out of stamina for this. Oh, really? So, okay. All right, pi over 2. Like that. And then, it occurs to me that these two vertical lines that I'm drawing, they could be anywhere. And so I should determine where they are by this. That's what I should have been doing, right? The vertical shift of -1 doesn't make a difference because it's tan. It'll just go down by 1. Okay. So also, if it's 11 pi over 12 to the right, isn't that the same as pi over 12 to the left? No. Okay, why not? Well, because the period is pi over 2, isn't it? Not pi. Oh, right. Oh, right. Well, how about this? How about if I shift my shift? Instead of being pi over 2, it could be 5 pi over 12, right? How about that? Okay, that's all right. And then that's what? A 12th of pi to the left? No. I'm going to have to come back to these. I really am. They're tough for me. Just put a mark in the book and see what else is cooking. Simple trig equations. Oh my, oh no. Yeah, there's just no way. Not right now. All right. Put a mark there to return back to it. And just do some derivatives, something like that. All right, be well, be well.